All right, class, we're picking up again, chapter 3, section 2. We're not going into section 3, but this will be part 2 of the video from the lesson today. So again, now we're getting out our periodic table. So if you don't have your periodic table, make sure you get it out because we're going to be working with it an awful lot. And so as we look at our periodic table, we've already gone through this, but we see that there's a key in the bottom of that periodic table. And we see the thing there where it says atomic number. The atomic number is just simply the number of protons each element has. Remember, we talked about last chapter that the atomic number identifies what the element is. Hydrogen is called hydrogen because he has one proton. Helium is called helium because he has two protons. So if you change the number of protons, if you change the atomic number, you are changing what element you're talking about. All right, so let's do some practice. What is the atomic number for mercury? What element has 20 protons? Quick review, quick practice, use your periodic table, pause the video, and then you'll get the answer. All right, we see mercury, look at my periodic table, has atomic, Hg has an atomic number of 80, which tells me he has 80 protons and his atomic number is 80. Then we look and see what element has 20 protons. Well, I go over and I count, and I see my calcium has 20 protons, atomic number of 20. So what we begin to see here, though, is that all neutral atoms must have the same number of protons and the same number of electrons. We already said if one proton equals one electron in opposite yet equal charges, then for any atom to be neutral, it has to have the same number of protons and electrons. So on your periodic table, you don't see any charges. There are no charges represented anywhere on your periodic table. So whenever you use your periodic table, assume that element is neutral. And in neutral atoms, the atomic number always equals the number of electrons too. Again, in a neutral atom, if I have a neutral atom, the number of protons equals the number of electrons, so our atomic number also equals the number of electrons. And you might ask, well, how do I, Mr. Lawrence? How do I know when there's a different charge? Well, on the board behind me, you will see in the top right corner when there are different charges being given to atoms. So here's a hydrogen with a positive charge. Here's a hydrogen with a negative charge. That tells me that I have one proton because it's hydrogen, and there's 0 electrons because there's a positive charge. So these two numbers get added together, and it gives the whole charge for the whole atom. Here, if I have a hydrogen with a negative charge, that means I have one proton with 2 electrons. One proton cancels out with 1 electron to leave 1 electron charge behind to tell me that my hydrogen here has a negative charge. Here is just a neutral hydrogen with no charge because the number of protons equals the number of electrons. And so again, assume all elements are neutral unless they give you more information. They put a positive or a negative or a +2 or a +3 or -2 or -3 in the top right corner. So what we now come to is this thing called isotopes. But before I go to isotopes, let me refer back to this. Do you see how they're the same element with just different charges, different number of electrons? Well, since there's a grouping of the same element with different charges, we call these isomers of each other. These are called isomers. There's the same element with different atoms, but different atoms of the same element, but they have different charges. Well, we now got these things called isotopes. So if you look over here on the board behind me, now we're going to see isotopes. Isotopes are the same atom, but yet with different number of neutrons or different masses. So here's a hydrogen, here's a hydrogen, here's a hydrogen. They all have the same charge, so which means they have 0 electrons like we saw before, but now we're changing their masses. We're changing how many neutrons they have. So when we look at the nuclear symbol, I'll show you on the next screen, the number on the bottom left is the atomic number. This is the mass number, and this is the charge. And when I have groupings of the same element, but they have different numbers, they have different masses, we call those isotopes of each other. And this right here refers to that 99.99% of the time in nature, hydrogen will have 1 proton with 0 neutrons. 0.01% of the time, you'll find hydrogen with 1 proton and 1 neutron. And in the laboratory, you can make 1 proton with 2 neutrons. So here we go, our mass number. Our mass number is a way that we will write the idea of how many protons and neutrons a given element will have. So we use a mass number to determine the isotopes. Which form of the element are we talking about? So our mass number is just simply adding up the number of protons and adding up the number of neutrons. So what would be an atom with 17 protons and 20 neutrons, and what would its mass number be? Well, the answer is written below in the number 37. I would add 17 plus 20 to get 37. And again, because it has 17 protons, I would go back and look on my periodic table. And after looking at my periodic table, I would see chlorine has an atomic number of 17. So that means 17 protons means it's chlorine. Mass number together was 37. And this is written in the hyphen notation form. Hyphen notation form. One thing I want to point out is look at chlorine's atomic mass according to its periodic table. It's going to say 35.45. That's because, again, this number on here is the average mass that you would find of chlorine out in nature. This happens to be 37. So this happens to be a chlorine with 2 more nitrogens than what you would find on average. If this was off your periodic table, this would be written chlorine 35, and that would show the notation of a chlorine with an atomic mass of 35. And again, we can round those decimals up or down because this is an average number, and this refers to the actual isotope you're talking about. So how will we do it in chemical nuclear symbol form? So just like you saw the hyphen form, here is it written in the chemical or the nuclear symbol. We put the mass number up top. Again, this is the number of protons plus neutrons. The atomic number is how many protons I have, and then I would write it with my elemental symbol. So again, you need to be able to recognize and write out isotopes in this form or isotopes in this form. And again, my mass number is just the number of protons plus neutrons. So here we go. How do I find the number of neutrons? I simplified it out. The equation is easily understood as this. My mass number, let me get my head out of the way, is number of protons plus number of neutrons equals my mass number. Or we can rewrite that equation to be the number of neutrons is the mass number minus the atomic number. So here's some practice. I want you to go ahead and pause the video, and I'll give you the answer. But what you need to do, though, is when you go to write your answer out, I want to see it written in this format. I want to see you put the number with a P, the number with an N, and then the number with electrons to show how many protons, neutrons, and electrons you have. So go ahead and answer these 3 questions, and I'll put up the answer here in a second. But I have selenium 79, which is written in the hyphen notation, how many protons, how many neutrons, and how many electrons are there. If I have aluminum 27, which is written in the nuclear symbol form or the chemical symbol form, how many protons, neutrons, electrons does this have? If I have oxygen 18, how many protons, neutrons, electrons I have? Now again, off the periodic table, you will notice the oxygen here has a different atomic mass than your periodic table because these are different forms, they're different isotopes of the same element. Good luck. If you have questions, feel free to email me, class. I hope all is well. Pause the video because I'm about to show you the answers. So here are your answers for these 3 problems. And now we have one more problem you need to be able to do. Write the complete chemical nuclear symbol for the isotope with 21 protons, 24 neutrons, and 20 electrons. Go ahead and do this yourself, but again, you need to write it in the chemical/nuclear symbol, not the hyphen. Pause it, and I'll show you the answer. All right, class, here's the answer for that last one. It's found in the bottom. Right there should be the answer you should have had. Thanks. Have a great day.